In this video, I will illustrate how to solve polynomial functions to find the solutions. As a reminder, on a graph, real solutions can be found as x-intercepts, but when solutions exist that are complex, it will not show up on a graphing calculator. Here's the first problem. Okay, so I'm going to start by factoring this. I know this breaks into 8 times 8, x squared and x squared, and 1 and 1. 8 times 8, 64, x squared and x squared, x to the 4th, 1 and 1. Oops, excuse me, that should be a subtraction sign. Each of these is referred to as a factor. Now I'm going to set the factors equal to 0. And I'm going to solve. So I'll start on the right. I'm going to add 1 to the opposite side. I'm going to divide by 8. Square root both sides. Recall this means there's going to be 2 answers, plus or minus. And so this says that one answer is positive square root of 1/8, the other answer is a negative square root of 1/8. There should be 4 solutions. These are 2 of the solutions. So I plug this equation in, 64x to the 4th minus 1. And then I go ahead and graph it. You're welcome just to watch my graph here. And I want to confirm, is this correct? So the zeros on this graph for the x-intercept should occur at positive square root of 1/8 and negative. Second trace value, you can just watch, negative square root of 1/8. This is correct. I've confirmed it because y equals 0. Y equals 0. That is one answer. Second trace value, typing in the square root of 1/8. And there's my second answer. That also confirms that this is the second answer right here. So let's just, right here is my second answer, positive and negative square root of 1/8. Now I'm going to take the second factor, subtracting 1, 8, square rooting both sides, getting 2 answers. Oh, I can't take the square root of a negative, it becomes an I. And here's the other 2 answers, 1, 2, 3, and 4. But I cannot take these and plug them into the graph and show that they are x-intercepts. X-intercepts will only be shown for the answers that do not contain an I. These will not be visible on a graph. So here are our 4 answers. Example number 2, I'm going to start by factoring out a 2 and an x. 2 times 8 and 2x times negative 1. Alright, so I'm going to set each factor equal to 0, each factor. So 2x equals 0 and 8x cubed minus 1 equals 0. Well, this is easy. That tells me that one answer is 0. Let's confirm that and see if that works. I'm going to erase the previous one, typing in 16, x to the 4th, subtract 2x, and I should see one of the answers being 0. It looks to be true. Let's check. Second trace value, I'm plugging in 0. I should get 0 for an answer of y. That is true. This answer confirms. It's a real answer. It doesn't contain an I. I can check it on the graph. Now, hopefully you recognize 2, 2, 2, x, 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 1, 1, 1. Hopefully you see that as well. So this is a difference of cubes. Bring down a 2 and an x and a 1. Symbol remains the same. This is always positive. This is opposite of the front. 2 times 2 is 4. X times x is x squared. 1 times 1 is 1. How do I fill up the middle? 2x times 1 is 2x. Same concept. I take this factor, I set it equal to 0 and solve. Add 1 to the opposite side. Divide by 2. This states that another one of the 4 answers is 1/2 or 0.5. Let's check. Second trace value, typing in 0.5. I have y equals 0. That confirms that it is correct. Y equals 0 confirms this is the correct answer. Now, where do I come up with the other 2 answers equal a total of 4? Whenever you do sum and difference of cubes, this trinomial will always need the quadratic to be used to solve. So I'm going to go over the top here, 4x squared plus 2x plus 1. Okay, so x equals negative b plus or minus b squared minus 4ac all over, not over just this part, all over 2a. 2 squared is 4. 4 times 4 is 16 times 1 is still 16 over 8. So we can't take the square root of a negative, it comes out front. And by the way, 12 breaks into 4 times 3. Square root of 4 is 2, and square root of 3 is irrational. So I can go one step further here, recognizing that these three terms right here, and right here are all divisible by 2. X equals, divide by 2, negative 1 plus or minus, divide by 2, 1i squared root of 3, divide by 2 over 4. These are the other two answers. They are complex because they have an I, which means I needed a total of 4. I received 4. 1, 2. 2 of them are real. Remember, complex always comes in pairs of 2. These are the other 2 remaining. You will not be able to find those on a graph. 2 remaining examples. This is one of the 2. Our goal is to identify the solutions on a graph, both real and complex solutions to this polynomial function. So 1 times negative 36 is negative 36. Looking for a combination through factoring that multiplies to equal negative 36 and combines to give you negative 5. And that could be, let's see, 1 and 36, no. 2 and 18, not a difference of 5. 3 and 12, no. 4 and 9 work. A negative 9 and a positive 4 combined to equal negative 5, and they multiply to give you a negative 36. Take this degree 4 and divide it by 2. And because the leading coefficient is a 1, I don't need to divide here. All right, now let's look. We're going to take each one of these factors and set them equal to 0. X squared minus 9 equals 0, and x squared plus 4 equals 0. Remember, y will always be 0. Y will always be 0 when you're finding an x-intercept. That's why we set it equal to 0. I'm going to add 9 to the opposite side. So take square root. This tells me I should have 2 answers. And the square root of 9 is 3. So x equals 3 and x equals negative 3 should be our 2 answers. I want a total of 4. Now I'm going to take the 4 and move it to the opposite side. Take the square root of both. X equals plus or minus. You can't take the square root of a negative, comes up front. We know the square root of 4 is 2. So x equals 2i and x equals negative 2i would be your other 2 answers. Total of 4. Remember, complex comes in pairs of 2. And there's my final example for today. I'm going to start by seeing that I have x cubed, x squared, x, and no x is present. So let's try factoring by grouping. I'm going to factor out of 2x squared and be left with 1x minus 3. Okay, I'm going to copy and paste into the back. What times x is 1x? Positive 1. That times negative 3 is still negative 3. Front half, back half. They both have an x minus 3. Here's in front of the front first, in front of the second. Oops, excuse me. Remember, when you're trying to find the solutions, your y will always be equal to 0. And that's the reason why we take each one of these and set it equal to 0. I should have a total of 3 answers. Add 3 to one side. There's 1 answer. Subtract 1 to the opposite side. Divide it by 2. Take the square root of both. You can't take the square root of a negative. There should be 2 answers. That comes up front as an I. Here's my 3 answers. I can confirm this one on a graph. So, if I type in 2x to the third, subtract 6x squared plus 1x minus 3, and I graph it, this should be where I see an x-intercept. Second, trace the value. I type in 3. I should have a y value of 0, and I do.